So a bag contains 5 green marbles and 6 red marbles. Now, if 2 marbles are chosen successively without replacing them, what is the probability that 2 red marbles are chosen? So again, we could say first you're going to choose, first you're going to choose your first marble, and it could be either green or red. And there's 5 out of the 11 are green, and 6 out of the 11 are red. Now you're going to pick out a second marble. So now off of those branches, it could be green and red again, and green and red again. But now it's not going to be 5 out of 11 for green. What number is going to be on this branch? 4 out of 10, because we've already taken a green one out. So now there's only 10 left and only 4 green ones left. There's still 6 red ones out of the 10. Notice that 4 out of 10 and 6 out of 10 add up to 1. And then over here, 6 out of 11, there would be 5 out of 10 green ones and 5 out of 10 red ones left. Now, some of you will be able to get to the point where you don't even have to draw tree diagrams for a question like this, because you can imagine you want to find the probability of red and red. And so there's only one branch for that. And what is it? And then you say to yourself, well, what are my chances of getting a red one on the first one? 6 out of 11. And what are my chances of getting red on the second one? 5 out of 10 for 30 out of 110, or 3 out of 11. At least one green marble is chosen. So if we think about this, at least one green marble chosen from here, you can see that that could be this branch. That could also be this branch or this branch. So we have 3 cases. So we could show it as that's equal to the probability of getting green and green plus the probability of getting green and then red, or the probability of getting red and then green. So putting that together, green and green would be 5 out of 11 times 4 out of 10, plus green and then red would be 5 out of 11 times 6 out of 10, plus red and then green would be 6 out of 11 times 5 out of 10. And we're getting a 20 plus 30 plus 30, 60, 80 out of 110, or 8 out of 11. Now, again, whenever you see at least, another way of thinking of things is, what's the opposite of getting at least one green? Getting no greens, or getting both reds. So if we figured out what the probability of both reds were, red and red, and subtracted that from 1, because 100% minus the probability of getting both reds should leave us with the same answer. Now, what's the probability of getting red and then red? Well, we figured that out in part A. That was 3 out of 11. And if you do 11 out of 11 minus 3 out of 11, sure enough, you also get 8 out of 11. That takes a lot less work than adding up your 3 cases. So often doing the complement or doing the opposite is a nicer strategy, especially if I would do this like saying, oh, I'm going to pick marbles out 6 times. Then the probability of getting at least one green would have tons of cases, but there would only be the one branch that was all red all the way through. One more question, then we'll get our test back. Two bullseyes. So we can draw a diagram. Here's our first shot. You've got a bullseye. I'm going to call that as a hit and a miss. He's got 80% chance of hit, 20% chance of miss, and then we could go hit and miss again. And since they're independent, he doesn't get better, he doesn't get worse. It's always 80%. Very consistent. I know, impressive. So there's our situation with the tree diagram. What's the probability he hits a hit and then another hit? Well, that would be 0.8 times 0.8, a 64% chance that he gets 2 hits in a row. He only hits 1, well, that would be either a hit and a miss or a miss and then a hit. So you see that there's 2 cases of only hitting once. And this is what, if you don't draw the tree diagram, sometimes you just think of the 1. Well, we get 0.16 plus 0.16, 0.32 chance of that. Hits at least 1 bullseye, that would be everything. I'm going to do everything but 2 misses. You could add up all 3 cases. In fact, it wouldn't be hard because we've got only 1 bullseye plus 2 bullseyes. We could just add up A and B to get it. Or if we subtract both misses, we get 0.96 that way as well. So there's some exercises to work on.